Two down, Unit 3, Analytic Trig. So we're going to do some simplifying and maybe even verify some trig expressions. First thing, if it says simplify the trig expression, when you see secant and tangent, I always try and start off with, can I do this by just converting everything to sine and cosine? That's cosine x over 1, and then the denominator, remember tangent is sine over cosine. So let's focus on the numerator here and get a common denominator. If this is cosine and this is 1, this guy's going to need a cosine, and this guy's going to be fine. So this will now be 1 minus cosine squared x over just the cosine of x. On the denominator, I still have sine of x over cosine of x. So now we've got a fraction divided by another fraction. Let's do copy, change, flip. 1 minus, wait a minute, 1 minus cosine squared, that's sine squared. So this is sine squared. I'm just going to simplify that over cosine of x. Numerator, change to multiplication, flip the denominator, cosine of x over sine of x, and now let's see if anything cancels out. Cosine, see ya. This is sine of x times sine of x, so one of those cancels out, and you're left with just the sine of x. Sweet deal. Let's try another one. Sine of theta over cosine of theta. I can't convert to sine and cosine because it's already done, and I don't see anything squared or any identity, so I'm going to have to just get a common denominator. This guy needs a 1 plus sine of theta, which if you do it in the denominator, you have to do it in the numerator. And this guy needs a cosine of theta. Same deal. So now I have my new fraction. I know my denominator is going to be 1 plus the sine of theta times the cosine of theta. Numerator, I'm going to distribute. Sine of theta times 1 is the sine of theta. Sine of theta times sine of theta is sine squared. And up here, I have cosine squared. So now I see sine squared and cosine squared. That's usually a good thing. That is 1. So now I have sine of theta plus 1 over 1 plus sine of theta times cosine of theta. And hey, look at that. Sine of theta plus 1 is the same as 1 plus sine of theta. So those can cancel out. You have 1 over the cosine of theta, which is the secant of theta. So we're done. Simplify each trig expression. You need to know your double angle formulas, and the double angle formulas such as like cosine of 2 theta is the same as cosine squared of theta minus sine squared of theta. So when you see this, cosine squared minus sine squared, that's saying this is the cosine of 2 times 14. This is the cosine of 28. Now you can't, it's a sweet like an 8. You can check this just by saying cosine of 28 and then doing cosine of 14 squared minus sine of 14 squared, and we better get the same thing. Okay, good. So you can kind of check these. This is another double angle formula. This is the sine of 2 theta is 2 sine theta cosine theta. So if you see 2 sine cosine, you should say, oh, that's the sine of 2 times 5, which is the sine of 10. And again, you can check that as a decimal. Evaluate inverse trig functions. So you got to be careful because these have restricted ranges. If it says the inverse sine is radical 3 over 2, you have to know that inverse sine and inverse tangent both work in quadrants 1 and 4. Inverse cosine works in quadrants 1 and 2. So we're up here. For the first one, inverse sine, I know I'm in here somewhere, has restricted range. So if you tell me the inverse sine is radical 3 over 2, there's only one quadrant in which sine is positive, and I want to know the angle that goes with it. You're telling me that the sine, the y value, is radical 3 over 2. I want to know what the angle is. Well, that's across from the 60-degree angle, or in radians, pi over 3. Cosine, inverse cosine, is restricted to these two because cosine can be positive in the first and negative in the second quadrant. So if the cosine is radical 3 over 2, then we're talking about this, which means this is 1/2, which means you're talking about 30-degree angle, which in radians is pi over 6. And the last one, if cosine is negative, then that puts us over here. So this is negative radical 3 over 2. That means this is 1/2. It's a 30-degree reference angle. When you're talking about inverse cosine, this is the angle we're actually looking at. That's 150 degrees, which is 5 pi over 6. If it doesn't specify, I'd say go with radians, but it'll usually tell you. Solve the trigonometric equation. Last one for unit 3. We have to isolate cosecant squared first. So let's add 3. 3 times the cosecant squared of x equals 4. Divide both sides by 3, and you have 4/3, which when I see cosecant, I'm thinking, I'd rather work with sine. So I'm going to flip both sides of this fraction and say that's the sine squared of x equals 3/4. Now that I have sine squared, I can say I want to get sine by itself, so I square root both sides. And the sine of x is, when you square root, plus or minus radical 3/2. So you need to be able to ask yourself, where is the sine plus or minus radical 3/2? So all the reference angles that are 60 degrees is where sine is radical 3/2. If this is 60 degrees, this is 60 degrees, or that's 60 degrees, or that's 60 degrees, or that's 60 degrees, the sine is either radical 3/2 or negative radical 3/2. Here it's positive, down here it's negative. So what are all those angles? Well, this angle I could reference as pi over 3, and then I could pick up this guy by saying plus 2 pi n. So that's one set of solutions. I've got those. Now I need to say the other one would be 2 pi over 3. So 2 pi over 3 plus also, not 2 pi n, just pi n. Let's fix that. That'll be done. Pi over 3 plus pi n, and then 2 pi over 3 plus pi n. That way I don't have to say all 4, I can just say each one of these. And those are all of my answers. So that's it for Unit 3. Maybe I'm going to stop this.